Myself Yusuf and welcome to the video about seismic design of building in ETEP. For seismic design, I have used same model which I use for tall building and location of the building is in Vadodara. So as per IS 1893, Vadodara is located in zone 3. So I have to design building for zone 3. Now you can see that I already generated the model. Now for seismic design, I have to define a new load pattern which is seismic. Here you can see that I have already defined dead load, live load, SIDL and wind load. Now extra is seismic. Here select seismic and here IS 2016 and click on add new load. Now I only consider load in X direction, so I have to remove tick mark from Y direction and X direction with eccentricity. Now for Vadodara, which is situated in zone 3. Now for seismic zone 3, zone factor is 0.16. So I have to use Z value is 0.16. Site type 2, importance factor 1 and response reduction factor 5 and click on OK. Now I have to add new load combination of seismic. So I have to first remove complete frame design. OK, and click on analyze the model, run analysis. Now you can see that displacement of building due to dead load. Now you can also see displacement of the building due to seismic. This is due to seismic. And we also check for different combination from this. We can directly see the support reaction. This is support reaction, shear force and bending moment diagram. This is due to dead load. Now we have to see for seismic. This is due to seismic and shell stresses. This stress is due to seismic. After analysis, we have to design the building. For that, we have to go on first design, concrete design, start design and check. Now you can see longitudinal reinforcement detailing. Apply for in plan. You can see all the details about beam, which we have also seen for tall building in case of wind load, dead load and live load. Flexural detail 428, regular 240, seismic 428, shear detail, enveloping summary. Here we can also see what type of failure occur, identify shear failure. Here no shear failure. Now for column, you have to go on elevation. Another detail about column. Flexural detail, shear detail, joint shear detail, and envelope interaction curve for column. Okay, now we have to perform a response spectrum. For that, I have to first unlock the model. Now, for response spectrum analysis, you have to first define a function called response spectrum. Here select IS 1892.16, add new function, name is RS. For our problem, seismic zone 3, all value is same, click on OK. Now define load cases, add new case, response spectrum. You select response spectrum, add acceleration function RS. Here scale factor is the value of Ig upon 2R. In our case, I is equal to 1, G is equal to acceleration means 9810, and R is equal to 5, which means Ig upon 2R value is 981. Add now acceleration U2 is also same value 981. Here SRSS. Okay, click on OK. Now we have to analyze building. Here do not run case because we have already analyzed for this. Seismic and response spectrum only For seismic and response spectrum, we have to analyze the building. Click on run now. Now analysis is a bit long process, so I skipped that part in a video. Now we can also check the story response plot. This is of maximum story displacement. Maximum story displacement permissible is h upper to 50. H upon 500 is 0.138. So it is less than 0.138. Okay. For response spectrum and for seismic, it is in mm. That value is for meter. Now maximum story drift, it is permissible is 0.004 h. Our value is 0.276. It is very less than 0.276. Then therefore okay. Okay. Now next part is we have to design the building. So go on concrete frame design, start design, check. Design process taking too much time, so I skipped that part in video. So you can see a longitudinal reinforcing detail, same as tall building design. You can also check verify all member pass or not, all concrete frame pass, design check, and display design information like longitudinal reinforcing, rebar percentage, shear reinforcing, same as tall building design, and also for details, flexural details. Envelope, for column 500 by 500 column, bar area percentage, all flexural detail, shear detail, interaction curve, same as tall building. Okay, now we have to perform a time history analysis. So we have to unlock the model again. Now we have to perform time history analysis. For that we have to define a function called time history. I have already added, but I again add new function, name as time history th, file is example. It is a time history file of Bhuj earthquake. Bhuj earthquake here. I'm okay. Click on OK. You have to name. Okay. Now we have to define a load cases, time history, a date, modify time history. Here select TH, scale factor is same as IG upon 2R means 981 in our case. Okay, and then click on OK. Now we have to analyze the building. Therefore set load cases to run. Already set. Now run now. Now we can see time history plot of the building. It is showing maximum and minimum base shear with at a time it will occur. Yes, select TH. OK. Now we can also see a combined story response plot. Like displacement, drift, base shear and overturning moment. We should check that maximum drift should be less than h upon 250 means 0.04 h. Now next step is to design the building, which is same as we have done in a tall building design. Now design is a very long process, so I skip that part in the video. Now we can see that all the member passed or not. All concrete frame path check. We can also check design detailing of beam and column, same as tall building. Concrete beam design, summary flexural detail, shear detail, envelope. You can also check column details, 500 by 500 column, T bar area 2000, percentage 0.8, flexural detail, shear detail. You can also check the interaction curve for column. Now we can also see that ETABS generate report, project report and summary report. Like summary report like this. All the data will be given: base reaction, story forces. So with this, we have completed the seismic design of the building in ETABS. Thank you for the watching.